In our last video, we introduced point estimates, which are single values that we use to estimate a population value that we don't know. In this video, we're going to talk about the three properties of a good estimator. First, the estimator should be an unbiased estimator. Next, the estimator should be consistent. And lastly, the estimator should be relatively efficient. Those three terms in bold all have very specific statistical meanings, so let's look at what each of those means in a little bit more detail. We'll start with unbiased estimators. This is the biggie. An unbiased estimator is one in which the mean of the estimators that we obtain from repeatedly sampling from that same population using samples of the same size. So if I'm talking about height of US adults, I'd repeatedly grab samples of, say, 30 adults and calculate their mean and do it over and over and over again. And if I were to calculate the mean of those samples, it should be equal to the population parameter that we're trying to estimate, in this case, the mean height. You'll notice that this is one of the relationships that we see for sampling distributions, and that's why we like sampling distributions. So the three things that we might estimate if we're estimating an average or a mean, we expect that the mean of the sample means is equal to the population mean. If we're estimating standard deviation, we expect that the mean of the sample standard deviations is equal to the population standard deviation. And if we're estimating proportions, we expect that the mean of the sample proportions is equal to the population proportion. And these are all things that we expect to see when we deal with sampling distributions. The next requirement is that we want our estimator to be a consistent estimator. And an estimator is consistent when, as that sample size increases, the value of the estimator approaches the population value. Meaning, if I am estimating the mean height of US adults, as I increase my sample size, that sample mean gets closer and closer to what we know the population mean is. So for example, if we are talking about the average height of US adult men, we know that that's 5'10". So I would expect that as I collect bigger and bigger samples, 1,000 people, 10,000 people, 100,000 people, the average height of that sample of US adult men should get closer and closer to 5'10" as my sample size gets bigger. Our last requirement is that we want a relatively efficient estimator. And a statistician considers an estimator to be a relatively efficient estimator if the estimator has the smallest variance of all of the possible estimators that I could choose. The upside is that you don't actually have to check for these in this class. We're going over them because if you are a practicing statistician, you need to check that the estimators that you use meet these requirements. The ones that we're going to use throughout this course have already been checked and meet those requirements. In our next video, we're going to start talking about the second type of estimator that we can use, which is called an interval estimate. If you have any questions, you can reach out to me via email or drop by office hours. Otherwise, I'll see you in the next video.